All right, everybody, welcome. I hope you're having an awesome day. Today we're going to be learning about the slopes of horizontal and vertical lines, and this is Mr. Giovanelli with you. All right, our essential question today is how can we prove that horizontal and vertical lines are perpendicular? We want to figure out how to have mathematical proof for this situation. All right, to kind of start off, let's review a little bit of everything that we've learned this week. So let's use what we've learned about coordinate geometry to prove mathematically, keyword, what type of quadrilateral ABCD is. So I can look at it here and then probably come up with some guesses of what it is, but I want to really be able to have the mathematical proof. So first, let's find the distances. So let's do AB. So the distance between A and B, I'm noticing that A is at 1, 2. And B is at 2, -1. So if I want to find the distance between those lines, I could use the distance formula, right? So we can say the square root of 1 minus 2, x2 minus x1, plus 2 minus -1, y2 minus y1. All right, and then that's going to give us -1 squared plus 3 squared. And if we just keep simplifying, we're going to have 1 plus 9. We're going to have the square root of 10. And that can't simplify anymore, right? So we could just keep doing the distance formula. I wanted to show you one example. But you'll notice, if you want to just kind of learn how to find some shortcuts here, this line we just found is the hypotenuse of a 3 by 1 right triangle. So a 3 by 1 right triangle will always give us a distance of the square root of 10. Well, if you notice, every side here is the hypotenuse of a 3 by 1 right triangle. So what that means is every single side here, AB, BC, CD, and DA, they all equal the square root of 10. So what we've just shown is that every side of this quadrilateral is the same exact size. Okay, so in the last part of this problem, we've proven that all the distances of each line are the same, right? So that gives me a little insight on what this shape could be, but I don't really know for sure until we take a look at the slopes. So let's do the same thing. Let's find the slope of AB. So A again is at 1, 2, and B is at 2, -1, right? So let's find the slope of AB, and that's going to be 2 minus -1 over 1 minus 2, change in y over change in x. That's going to become a plus, so we have 3 over -1, which if we want to simplify it is just -3. Okay, now we could keep doing the slope formula, definitely nothing wrong with that, but to save us a little time, I'm going to do just counting the rise over the run. So from B to C here, I'm going up 1 and then to the right 3. So the slope of BC is going to be 1/3, and that line is rising, it's increasing from left to right. So it's positive 1/3. And then looking at CD here now, I'm noticing that from D to C, we're going down 3 and over 1. So that line is decreasing from left to right. So the slope of DC or CD is also -3 over 1, or just -3. Okay. And then finally, going back to DA, from A to D here, we're going up 1 over 3 again. So from line, the slope of DA is also 1/3. So what we showed here with our slopes now, we have some information. We know that the opposite sides are parallel because they have the same slopes, right? And then we also know that where the sides meet, you're seeing that negative reciprocal relationship, or the opposite reciprocal relationship we talked about. These are the reverse of each other, right? You flip the sign, flip the fraction, so that means that we also have 90-degree angles. Okay, that got a little messy, so here's a fresh copy, and we can kind of really think about a conclusion of what we saw. So part 1, we showed that all the sides were congruent. In part 2, we showed that the slopes were opposite reciprocals of each other. So that means the opposite sides are parallel and that they intersect at 90 degrees. So we now have, without a doubt, mathematical proof that this is a square, because opposite sides were congruent, shown by the distance formula, and then intersecting slopes were negative reciprocals, showing the 90-degree angles, and opposite sides had the same slope, making them parallel. And that's what a square has. Okay, so the last little piece we need to get to today is what about horizontal and vertical lines? You're going to notice that something a little different kind of happens with horizontal and vertical lines. I do want to say that, finding the length, you can still use the distance formula, okay? You totally could take my word that you'll get the correct answer if you use the distance formula, but for the sake of today, if I want to know the distance between A and B, I could just count 1, 2, 3, 4, 5, 6, right? When it's a horizontal or a vertical line, I can just count. So A, B, and CD both equal 6 because they're just 6 units long. And then AC and BD are 4 units long. Okay, so when they're horizontal or vertical, you can count, but take my word for it, you can still use the distance formula. What we're really interested in on this page is what are the slopes going to look like. So what I want to do is I will calculate one of them, and then I want you to calculate the rest of them, okay? So let's do AB. So here we go, the slope of AB, and I'm seeing A is at -4, 2, and B is at 2, 2, right? So let's calculate the slope here. So let's go 2 minus 2 over 2 minus -4. Now you're going to notice we end up with 0 over 6. Now 0 divided by anything is always 0. So we have a slope of 0, which kind of makes sense if you think about this. This is totally a flat line. Okay? All right, I want you to pause it here and try the rest on your own. All right, what you should have noticed is that something kind of strange happens. So for BD, I filled in the coordinate points here. For BD, you have 2 minus -2 over 2 minus 2, which is 4 over 0. We'll come back to that in a second. For DC, you should have got 0 over something again. You would have gotten -2 minus -2 over 2 minus -4 again. So you end up getting 0 over 6, which we already talked about is 0, right? And then for CA, you should have got something similar to BD. You have 2 minus -2 on top, and then -4 minus -4 on the bottom, which is 4 over 0. Okay, so our question right now, we know that this is 0. What about if the 0 is on the bottom? Well, if you tried to put that into your calculator, you would get like an error message. The reason is you can't divide by 0. You can't divide something into 0 groups. So what we call this, when you're dividing, when you get a slope where 0 is on the bottom, you call this slope undefined. Okay, so what we have here is we have 0 slopes and undefined slopes. Vertical lines have undefined slopes, horizontal lines have 0 slopes. And that's what I want you to add to your notes. So a horizontal line, so a flat line going like this, is going to have a slope of 0 always. Okay, you're going to see 0 divided by some number, like we saw 0 over 6 on the last problem. A vertical line, meanwhile, is going to have an undefined slope. And that's when you're going to see the 0 show up on the bottom. It really doesn't matter what number shows up on top. It could be positive, it could be negative. If you get a 0 on the bottom, you can't divide by that number. So that means your slope is undefined. So important point here, these are not negative reciprocals. Yesterday or our last lesson we learned negative reciprocals proves perpendicularity, right? But this is also proof of perpendicularity. So this is a special case of perpendicularity because it means a perfectly horizontal line meets a perfectly vertical line, and by definition of what that means, that has to be 90 degrees. Okay? It really doesn't matter, just to emphasize this one more time, whether these numbers are positive or negative. All that matters is if the 0 is on top, it's 0. Okay? If it's like, I don't know, -7,000 over 0, it's undefined. Okay, let's try this one more time. So you can probably kind of guess what to expect here, but it's worth practicing. So why don't you pause this one? Why don't you practice it on your own? Let's find the slope of each of these lines. And we're using the slope formula in case you needed a reminder, but pause it here and find the slope of each line. Okay, what you should have noticed here, once you do the work yourself here, my work just showed up on the screen. What you should have noticed is that you get that same pattern where the horizontal lines, WX and YZ, those had the 0 slopes, and then your vertical lines, XY and ZW, had the undefined slopes. And you may be noticing a pattern of like the reasons why. if both your y coordinates are the same number, you're going to get a 0 on top of your fraction. If both your x coordinates are the same number, you're going to get a 0 on the bottom of your fraction. So that's why you end up with this situation with horizontal and vertical lines, because these points are in the exact same either horizontal or vertical position, so one of the coordinate points is getting repeated. So this is proof, again, that these are 90-degree angles. It's mathematical proof for what we can see visually. Okay, let's do one more here. So we're told that, or a couple more, line CD has a slope of 0, right? So let's figure out the slope of AB to see how line AB is related to CD. So the slope of AB, this is just having you do it without the visual. So the slope of AB is 11 minus 3 over 4 minus 4. And that's going to be 8 over 0. Okay, 0 on the bottom, that automatically means it's undefined. So that means if this is undefined and our original slope was 0, that means CD has to be perpendicular to AB. And if you had graphed it, if you wanted to see it, you could see that AB is going to give you that vertical line, and something with a 0 slope is just going to be a flat line like you see there. Okay, this is the last one we're going to do today. So let's figure out if line CD has these points given, is line CD parallel, perpendicular, or neither to these slopes that are given? So let's first find, oh, this should have said A and B here, that got caught, that's okay. Let's first find the slope of CD to figure this out. We can't really compare it until we know the slope of CD. So the slope of CD, let's say it's 7 minus 7 at the top, and then 3 minus negative 12, so we have 0 over 15, which is 0. Okay, so the slope we're comparing to is 0. So let's see this one. Well, here, our 0 is on the bottom, so that's undefined, so that means that we are perpendicular to CD, right? So this line here is going to be perpendicular to CD. All right, 3 over 2, that's going to be neither. It's going to be neither perpendicular or parallel because we have a slope of 0 versus a slope of 3 over 2. Over here in part C, this is a 0 here because 0 is on top. So these two lines are going to be parallel. So same slopes, right? Parallel. And then finally, to make us do a little work down here, we're going to get 6 over 0. So there's undefined again, which I'm going to abbreviate. So that means, again, we have a perpendicular relationship because we're comparing to a 0 slope. All right, if you want a little more about the why and even getting a little bit ahead into what we're going to study next week, you can check out this Khan Academy video. You're now ready for today's exit ticket, which is kind of a mixed review of this whole week. Make sure you're writing your answers down on scratch paper because you'll have to upload that. Good luck to you guys. Have a great day.